Ladies and gentlemen, I am pleased to welcome you to the Blackstone Battery Day here in Döbeln, Saxony. Today is Tuesday, February 16th, 2021, and this is a very special day for us. It is important for us to ensure that the manufacturing of our battery cells is ecologically sound. And that is why there are a few important points that I would like to mention. I would now like to speak briefly about Blackstone technology, how our company was founded, and what its purpose entails. In December 2018, our parent company, Blackstone Resources, decided to found a company in Germany for the development and fabrication of battery cells using a disruptive of manufacturing technology. Since then, a great deal of money has been invested in the development and manufacturing processes used, as well as in the development of the product itself, which I will introduce to you today. The development of these products is very complex. That is why, since our foundation, money has not only been invested in the development of this product, but also in a further development which we call solid-state battery cells. Here we will also develop the printing of these cells. We are already working on it. Furthermore, we are also working on the upscaling of a solid-state electrolyte technology developed in Switzerland. That is to say, the production in certain quantities that can later also be applied to this type of innovative cell. But now, briefly to the creation of this kind of battery cell, whose development is extremely complex. Sample cells are developed in laboratories by capable experts. A large number of tests are run. Finally, these sample cells result. But now, briefly to the creation of this kind of battery cell, whose development is extremely complex. Sample cells are developed in laboratories by capable experts. A large number of tests are run. Finally, these sample cells result in sample electrodes in their end size. As you see, these are an anode and a cathode, the main components of a battery cell. Then in the next step, we arrive at a sample cell. And today I would like to present to you a battery cell which we will be bringing into pre-production at this location in Döbeln this summer. And then next year, in January, February 2022, it will go into serial production. In order to do this, we have been making many preparations over the last few months at this location. One important preparation is, of course, the construction and erection of suitable manufacturing machines, which, as you can see here, are extremely compact. Where the required pastes are produced, where the 3D printing process is implemented, a drying line and its corresponding press can also be seen here. It is extremely important to us that this kind of battery cell and battery electrodes are based upon a sustainable and clean battery environment. It simply isn't enough to produce the necessary energy in a green or eco-friendly manner. More importantly is to use as little energy as possible during production.
Viel entscheidender, eben wenig davon während der Produktion zu verbrauchen.
And so we are able to use 78% less energy compared to conventional battery fabrication, especially in regard to electrode production. And calculated over the entire production, we still manage to conserve 35% more energy.
Einsparung an Energie.
So where do these energy savings come from? We don't have to utilize a drying room for our production. The production of the pastes we use for the coating of our metal films is both very fast and efficient. And these pastes have a high viscosity. That means that they contain very little solvent, which would otherwise have to be steamed out later.
Dort befindet sich sehr wenig Lösungsmittel drin, welches man dann später ausdampfen muss.
Additionally, no toxic materials are used in these solvents, just water. This is water-based processing for both the cathode and anode. The battery cell that results from this process has unique characteristics. It is stronger than other battery cells in electrode density and is therefore able to store more energy.
Hat besondere Eigenschaften. Sie ist in den Elektrodendicken stärker als andere Batteriezellen und damit kann man mehr Energie speichern. Das bedeutet, Sie können später in der
What that means for later application is that you can, for example, drive a car further. With 20 to 25% more energy in a cell that's manufactured this way. That's the reason we print these cells. By this summer, we will achieve an energy density of 220 watts per hour per kilogram in pre-production and in series production. Battery experts are also able to recognize that this is without a doubt a world record set at this location in Döbeln.
Frauen können jetzt erkennen, dass das durchaus ein Weltrekord ist, den wir hier am Standort Döbeln in Sachsen erreichen.
I'd like to express my thanks to Ulrich for joining us from Switzerland. I now hand the presentation over to you, Ulrich.
Übergebe ich jetzt das Wort.
Thank you, Holger. Dear viewers, welcome to our battery factory in Döbeln. I am Ulrich Ernst, the CEO of Blackstone Resources in Switzerland. We are responsible for these developments at Blackstone Technology in Döbeln. The goal of a battery factory is to set up a preliminary battery production of 5 gigawatt hours per year. We intend to achieve this goal as soon as possible. After that, we plan to double the capacity every year. In general, it must be said that the demand for batteries will increase substantially over the next 10 years. We believe that it will increase 10 times from where we are today. A market volume of $100 billion will develop from this trend. Over the next few years, automobile manufacturers will be rolling out 185 new models. This will likely lead to a tenfold increase in demand for batteries. Battery metals or metals used for these batteries, such as lithium, cobalt, manganese and nickel. Blackstone has a portfolio of investment interests in these metals. The most important of these metals is undoubtedly lithium. No matter what the battery manufacturing model, which construction, every modern battery requires lithium. That is why Blackstone Resources has taken ownership of 8,000 hectares, or an equivalent of 80 square kilometers, of lithium lakes in Chile. These will ensure reserves for battery production for decades. That is, in short, what we do here. Thank you. I will now hand over back to Holger. Thank you very much, Ulrich, and for the information you have given us. In addition, I would like to mention that the company Blackstone Resources AG, which is located in Bar, Switzerland, is listed as BLS on the Zurich Stock Exchange. The battery cell mentioned, the one we will be producing here at the factory in Döbeln, is based on a cathode material made of lithium iron phosphate, or LFP for short. This material contains neither cobalt nor nickel. Compared to other battery materials, it has a low energy density. Because of our manufacturing technology, thick layer technology, we can, however, cancel these disadvantages and raise the energy density. In addition, it is very important that the printing of battery electrodes and battery cells leads to the ability to print batteries in various form factors. That means that the customer can decide which shape the battery cell has within certain restrictions. This is very important for applications such as civil drones, where the battery is built into its wings. We can say that this very compact manufacturing technology requires significantly lower investment costs as well as significantly lower operational costs. I have already mentioned the sustainability of the water-based processes used, as well as the compatibility for new battery technologies like the solid-state battery. Important for us is that, as a subsidiary of Blackstone Resources, we are able to access their resources, which also makes us able to provide dependable delivery far better than other companies. And today, all of these advantages have led to customers who are interested in us and have approached us. And we have already come to corresponding agreements to deliver batteries for their applications. And with that, ladies and gentlemen, I would like to close and take the opportunity to answer your questions. For this, I would like to meet with my colleague Sandra. Ladies and gentlemen, we are now coming to the questions you have asked during our live chat. My co-workers have compiled answers behind the scenes, and now I would like to take this opportunity to introduce you to my colleague Sandra. Sandra is our head of process automation, and this job entails extremely important responsibilities. Above all, setting up the serial production system, the implementation of artificial intelligence, in particular for quality control, and the implementation of Industry 4.0 technologies.
Von künstlicher Intelligenz, insbesondere zur Qualitätssicherung, und das Einführen von Industrie 4.0, inklusive digitalen Zwillingen und alles, was eine moderne Produktion ausmacht.
So, Sandra, were there any questions from the audience during our presentation? Yes, we had quite a few questions. The first question I would like to address: will you also be able to print complete battery cells in the future? Yes, that is in fact our intention. Battery cells consist of various layers, and there is nothing more suitable than printing them. Because of that, several layers of anodes, cathodes, and separators can then be built up upon each other, but even the entire casing as well. So that is exactly the goal which will be attained. Another question from our audience is, how many employees are currently working on this project? At the moment, we have about 40 people, both internal and external people, who work together for Blackstone Technology. Among those are employees from institutes, research centers, as well as affiliated businesses, and this is just the beginning. Over the course of the year, we will be hiring further employees here at the Döbeln location in order to begin production. The next question from our viewers is printing fast enough? Printing, especially the screen printing method, is absolutely a fast method. Many of you will relate screen printing with newspaper printing and remember what a high-speed process that is. As far as this goes, we are positive that we will be absolutely competitive at a clock speed of 1 second per battery cell regarding speed. Where do the machines and equipment come from? The machines and equipment that we have ordered and which are currently being built come exclusively from German machine and equipment builders. Where do the raw materials come from today? The raw materials that we process come exclusively from Europe, and this is where we will concentrate our focus for the future, because we believe that transporting raw materials across the globe doesn't make much sense from an ecological battery production perspective.
Wenig Sinn macht für eine ökologische Batteriezellproduktion.
Our viewers would also like to have more questions answered. I have another interesting question here. How many gigawatt hours per year do you plan to produce in Döbeln? We have moved into a facility that has a total surface area of 6,000 square meters, and we can achieve a half gigawatt hour production capacity in this building. On the adjacent plot we can, or we plan, for an additional equal capacity. And the possibilities for expansion in this region are more than available. So as far as this is concerned, I have no worries that we wouldn't be able to fill our customers' needs. In addition to this, expansion won't only take place in Germany. Expansion will take place where our customers receive their batteries. Do you plan to produce battery cells with cathode materials other than LFP? Absolutely. So, development has already been started with another battery type, with an additional cathode material. That is NMC. Experts will know what is meant by that. But it would be too much to go into detail here and today. And that's not the end, it's only the beginning. I would like to conclude on that note and thank you all very much for your interest and for tuning in. I hope to see you all again on this channel very soon with exciting news. Thank you very much.